Dear students, last class we derived electromagnetic wave equation in terms of E. Wave equation is a second order partial differential equation. It describes the characteristic equation how the electromagnetic wave propagates in a medium or in a free space. During the process of deriving the second order, the partial differential wave equation, we used all the four different Maxwell equations to come to the conclusion. I advise you to watch this video to understand how we can derive the electromagnetic wave equation in terms of magnetic field intensity H. This is the equation of the first wave equation we derived. Here we can see that the wave equation is a function of E. And in this class, I am going to derive the electromagnetic wave equation in terms of magnetic field intensity H. The Maxwell's equation from Ampere's law in point form is given by so divergence of H is last module we derived this expression. Now taking curl operation on both sides, this is the same way we did for deriving the wave equation in terms of E. So this becomes epsilon the curl of the partial equation of E. But the Maxwell's equation from Faraday's law states that curl of the field intensity, electric field intensity is minus mu partial derivative of magnetic field intensity. Now differentiate this function. Let us take this is number 1 and we differentiate this function with respect to t. Differentiate this function with respect to t. So 1 becomes let us take this as equation number 1 and this is equation number 2 and this is equation number 3. Now substitute the expression of 2 and 3 in 1. So 1 becomes, the expression of 1 is curl of H is equal to, the first term is, this is replaced with equation number 2 is sigma minus mu sigma Similarly, this also get replaced with equation number 3. Minus mu sigma instead of the curl of partial derivative of E, we can write as second partial derivative of H. Take this as equation number 4. Now, using identity theorem, we can expand this function as divergence of H minus del square H. But we know that the Maxwell's fourth theorem states that the divergence of B is 0. The expression of B is mu H. Let us substitute this expression in the previous, so this becomes so definitely this can become 0. Hence, the previous expression can be rearranged as curl H is minus del square H. Let us take this as equation number 5. Now look at equation number 5 and equation number 4. We can compare both 4 and 5. H become minus mu sigma, the partial derivative of H minus mu epsilon, second partial derivative of magnetic field intensity. So minus is common. Rearrange the expression. It becomes minus mu sigma dash 30 minus mu epsilon, second partial derivative of intensity. This is equal to 0. Now look at the expression. the terms consist of H. In the previous expression, all these terms were E. Now all the E's are replaced with H. Hence, this is the wave equation in magnetic field. Now we can again write this expression, square H minus mu epsilon square d2 square is equal to 0. So this is the second equation, second wave equation. The first wave equation was del square E minus mu epsilon sigma dou H dou T minus mu epsilon dou square E by dou T square. Sorry, here is E. This is the first wave equation. So both the equations are very easy to by heart. Just replace H with E, you will get the first wave equation. If you do the vice versa, you will get the second wave equation. So both the wave equations represent the characteristics of electromagnetic wave propagation in a conducting medium. Again, we are going to derive the expression first and second wave equation if electromagnetic wave propagate in a free space. If wave propagate in a free space, in a free space, we already discussed, this is 0. If wave propagate in a free space, sigma equal to 0. Sigma is nothing but the conductivity of the medium. So in a free space, conductivity is 0. So what will happen to the previous expression? So both the first and second wave equation. If you look at here, this becomes 0. Or substitute sigma in the second term of wave equation. So wave equation can be rewritten as zero del square E minus mu epsilon dou square E by T square equal to 0. So these are the two wave equations if electromagnetic wave propagate in free space. Again, in free space, mu equal to mu naught mu r, and epsilon equal to epsilon naught epsilon r. These terms become 1. So the mu become mu naught, epsilon become epsilon naught. Again, we can replace mu naught epsilon naught is equal to 1 by